I would say this coffee mug is the transport layer, and whatever you pour inside is OPC right? So, for example, you can just, I think that's a bad example. So we can imagine a truck, right? A
Actually, it
truck.
isn't. You can put poison. Actually,
Yeah, you
it's a
can
good
put poison.
example.
Hello, everyone, and welcome to Coreflux Connections, our webinar series where we sit down with digitalization experts so we can learn from their experience and unique perspectives on the state of Industry 4.0 and IoT in general. Today, in the Coreflux Corner, we have Hugo Vaz and Rafael Soares, and we're joined by none other than Melvin Francis. Together, we're attempting to set up a data pipeline demo where we can go from the factory floor to the cloud in under 30 minutes. Let's see how that goes. And then we'll take some time to share some experiences and each other's perspectives on the current landscape of digital transformation. All right, everyone, would you like to go ahead and introduce yourselves to kickstart this show?
So maybe I will start. So my name is Hugo Vaz, and I'm normally one of the co-founders of Coreflux. And usually what I'm more focused is, and I really like, is this construction of these pipelines and to have different protocols and to handle those different protocols. So in here, I'm very interested about what OPC UA will bring. And
Okay, so hello everyone. My name is Rafael Soares. I'm a junior backend developer here at Coreflux. At the moment, I'm developing the OPC UA assets, so I believe this webinar will be an asset to better understand what this protocol does.
Great. Hello, everyone. Hello, Hugo. Hello, Yael and Rafael. Hello to all the viewers of this podcast. And thank you for hosting me today. And I'm hoping to have a lot of fun. So, to introduce about myself, I've been into industrial automation for close to a decade now, and I'm currently managing the OPCA plus TSN related projects at BE Services. So, especially into UAFX, which is OPCUA for Field Exchange. And we are going to discuss a lot about it today. And I'm also happy to answer your questions. And also, we are going to showcase a demo where we are going to push the data from factory flow to the cloud. And it's going to be OPCA Matricon, which is a BE services integration to Coreflux. So I'm going to hand over the data from the factory floor to the cloud, and we are going to see Hugo and team playing with the data by end of this podcast. And that is the plan. I hope everything goes well. Thanks for the great introduction, Yao.
yeah, so so maybe you already started, Melvin, but that's the general idea. So what we really want to do is to bring out the best of two worlds. So in one case, you are bringing OPC UA, which we're able to really have let's say, a structure of data, and then to have MQTT, the event trigger that we have and that we are able to get from MQTT, and bring it out with the Flux assets that we have from Coreflux into a database that's running on the cloud. So we are mixing edge, cloud, OT, IT, and really we are bringing the best for us, which is we are dealing with someone that's handling integration, and that's what we really like, because those are the people that we kind of like to connect. Those are the people we like to develop. So maybe I will pass the ball to you, Melvin. You can showcase, you can start showing us what you have on OPC UA, what you're bringing up to the game here.
Sure. Yeah. So I will start with a quick presentation, and let me share my screen. As I told you, I'm working at BE Services, and I develop part of the development team of the product called eTSN, which is embedded TSN. And you can see a lot of details at etsn.io. So many of the viewers would be like starting. Maybe you might ask, what is OPCA? You might be a beginner. So to address everyone, so to realize the Industry 4.0 use cases, we would need the data to be flowing from the factory floor to the cloud with ease. And this paves path for the IT and OT integration. So these are the concepts that are being discussed in Industry 4.0. So for example, integration of digital technologies, IIoT, data analytics, automated and connected manufacturing. So, okay, now there might be a question like, now that we have integrated this, what is there for us? So this might be a question of a business owner. So these are the questions that I'm able to answer today. Are Industry 4.0 will give birth to a lot of business use cases like predictive maintenance, supply chain optimization, one piece per batch, just in time, pay per use model, and subscription model. So, for example, so I think predictive maintenance, many people would know. So, let me take a use case of just in time. So, imagine you have an inventory control. So you have to, so for example, if you need to load the stock for like 10,000 ships, then you need to have a lot of inventory control to be done. So if all the things are connected, the supplier will know the exact time that the semiconductor is going to end. So imagine that one resistor is going to be completed in the inventory control. So this data will be published to the service provider so that he can ship the needed parts at on time so that the inventory control becomes easier. And also pay per use model. So imagine like you buy a robot arm. So you don't pay for the entire robot arm, but you just pay for the number of times you're going to use it. So these are some interesting business use cases which are already available in the SaaS industry, software as a service. And for this to come to the industrial automation world, you need the devices to be connected. And this is what being said in Industry 4.0, and this is something that we are going to realize today. So for this to happen, vendor dependent and lack of interoperability in the current protocols, custom hardware requirement, different protocols needed to hand over the data from the factory floor to the cloud. So imagine the number of translations and the gateways that we are hearing now. So all these are scary, and separate network assets for IT and OT. So even when they integrate, IT and OT integrate, there is a scary thing like what we have to do with the security. So all these questions can be answered with OPCUA and the concepts around it. So that is what we are going to see today. And OPCUA is vendor independent. Why OPCUA and TSN is important is OPCUA is vendor independent, support of a range of transport layer protocols, including TCP, UDP, HTTP, MQTT, and AMQP with different QoS service. So on the field level, it also plays a critical role where you can use OPCUA for determinism, and also you can use it to push the data from the factory floor to the cloud. So OPCUA can be integrated with TSN, and you can go to low latency where you also control the robot with high determinism applications. And also you can use a transport layer like MQTT where you can push the data to the cloud directly with secure in a secure way. So with TLS, with application layer security and network layer security. So these are the things that are promised with different transport layer protocols. So you can quickly see here like a nice video where this particular controller is using our eTSN OPCUA FX SDK, and it is controlling the robot. So this is the APC, and you can see that it sends the data, and you are able to see that the robot is being controlled. The beauty of OPCUA is that since this OPCUA is running, this robot is running a OPCUA server, it becomes easy for us. So you can see that the data is something that is available here. It is easy for us to push the data from the factory floor to the cloud without any translations, with just the translation of with the use of different transport layer protocols. So to explain it clearly, you can see for real-time communications, you would use PubSub over raw Ethernet. And for controller to controller communications, you would use PubSub over UDP. And to push for the cloud use cases and the items that we are going to discuss today, we will be using PubSub over MQTT, where we will be pushing the data from the factory floor to the cloud with different secure protocols. So you can see the motor position, motor speed, homing position. These are some example variables that you would need to control the robot that we just saw here. So for this robot to do, we need certain variables. So all these values can be accessed either by client-server communication or the different transport layer protocols that I specified now. So today specifically, we are going to look at PubSub over MQTT, and this is the demo that we are going to do today. So to start with, I will be using Matricon OPCA Flex SDK, where it runs a OPCA server, publisher, and subscriber, and it will have an input and output, and this is running on a Raspberry Pi. So using OPCA PubSub over MQTT, I will be pushing it to the CoreFlex MQTT broker, and from there I will be using it using a Node-RED application, visualizing it, and we will have Hugo who will take over to see like what all data operations that he could do from the CoreFlex side. So Hugo, do you want to add
Yeah, maybe
some
I
items
can.
here? Sure.
Yeah, I can dive in here. So yeah, it's a good presentation. Makes perfect sense. So we are getting the benefits of both worlds, the positive sides. Yeah, the main thing that we want to show here is how easy it is to do it in 30 minutes, as João told. So we are going to focus a lot on passing the data into something that creates a database. So we are going to send from CoreFlux and have a connector that's converting from the CoreFlux SaaS broker into a database. In this case, we are going to use something that's running over DigitalOcean. So we are using the benefits of managed database on or in this case, PostgreSQL. So we could see the data from that point. First thing we should do, I think, is maybe to set up a broker for Melvin. So if you can give me the share, I can share the how easy it is
sure.
to
You can take it over.
to do this. So what we are basically, we are an MQTT broker that you can use it on a self-hosted solution. You can install it and you can download by yourself and install on your computer. And we have a bunch of connectors that you are able to install that can connect to database, to OT devices, like, and OPC UA is one of the protocols that we also use. But we also have the same solution on a SaaS broker. So it means that I can set up a broker for Melvin right now. So I will give it and create it with my own account. Let me just connect to.
Make sure you share all your passwords with us.
Yeah, I will do that. Actually, I will actually share it with my own personal one. So it's very, very personal. So I can set up by using Google or either GitHub or by setting up an email. Having the account on Google, it's quite easy to connect. So I can start a free trial. So it has MQTT over TLS, so it's already prepared. We have this number of regions that we can set up. And for Melvin, I'm going to set up, since you are in Germany, so I will set up on Frankfurt. And this will take a bunch of seconds to set up. So I will receive an email after I define that I want to start the trial. So I started the trial, so I will wait a couple of seconds just because I will collect an email, because we are setting up everything. So we are setting up the DNS, we are setting up the certificates, we are setting up the cluster for you, we are setting up the broker itself, we are putting the best configurations in terms of load balancing already into place. And all this work is already done. So the customer in the end doesn't need to keep doing this. Anyhow, we are able to do it. And this is set it up in 9 different regions. So if you want to have real low latency, you're able to get it. And I already have the email. Maybe I can share the credentials with you. I already received the email, so I'll just share the screen right now. If Melvin is able to give me back the screen, so you can see you receive the connection, the email connection with the user password. Yeah, I'm showing the password as you requested, João. So you asked to make sure, but you should not do this. Anyhow, so I'm sharing this only for them. So I'm going to send to Melvin as an email he can use. Maybe you can start. So on my side on MQTT, to set up the MQTT broker is already into place. So Melvin is able to get up and running.
Thank you, Hugo, for creating. That was pretty quick. And I also just received your mail. I think I can't share my mail screen. I'm just keeping it in a different monitor. So I think we have already done the setup number 1. So we have got the CoreFlex MQTT broker. So let me quickly copy paste it so that people can see. This is an example application. So let me, so I just pasted it here. So this is the broker and it's with TLS. So we are going to do it. And so for Huo, so this is the Matricon BE services publisher demo is the topic where I'm going to publish 2 variables. It's of type double. I want to keep the demo as simple as possible so that it's not confusing for beginners and also people who wants to really use it. This is a sample application. Don't think that this is what we can do. We can at least do 10,000 variables for every 1 second or more than that. So just I want to make sure that this demo is also there for people who are beginning and also for people who are looking to really integrate into their systems. So I'm just copy pasting it in the chat and you could check if you're able to get it. So I'm just logging into my Raspberry Pi and I'm going to hit a recompile and let me start it. Yeah, I've started it and so Hugo, now you should be able to receiving it. If let me check it on the MQTT Explorer. Yeah, so you can see it's BE services and you're able to see the packets that are publishing here. So let me go back to the demo diagram that we have done. So I got the CoreFlex credentials from Hugo, and then I updated it into my OPCA publisher publisher program that is running on a Raspberry Pi. And then I've already started to push it on the MQTT broker, which we saw it on the MQTT Explorer. So you can see that I'm transmitting the data. It's just a counter incrementing. And we can also view it on Node-RED application. Let me show you my Node-RED flow. So this is the Node-RED flow that I'm using. So it's Matricon BE services publisher demo. And then I'm just using a text UI variable to check if I'm able to. So this is the dashboard. So subscribe value is 60,000. So this is what I'm able to publish. So what is so this is how the data would look like that I'm sending. So for Hugo, you would need the JSON information. So
it's
this is the
OPCUA JSON.
So it's you can see it's in the OPCA JSON encoding format. It's the publisher ID. In the message, you can see the dataset reader ID, sequence number, and this is where the value is being published. So I could copy paste this particular JSON format so that you could, I'm pasting it in the chat for you. So
what we actually are are doing, and you can pass, and Rafael can start doing that. But I will show, in a sense, how we can transform this into something on the cloud. So I'm going to set up a database. I'm going to show at least on the partner that what we are doing. If you can give me the sharing of the screen, I can.
Yeah, so just before giving the screen to you, I want to reiterate what we have done so far so that our audience can follow. So first we created a broker and we got the credentials, which was the broker address, username and password. So with my OPCA SDK, that is from Matricon Flex SDK, I updated the broker address, port number, username, password. And then I hit a recompile. I load it on my Raspberry Pi, which is somewhere here. I wanted to set up another cam, so it's just running here. And I'm able to push the data.
I'll do some post-edit magic to show it, and you'll give me a photo later, okay?
Yeah, sure. Yeah.
And I'll put it right here, right now.
Yeah. Okay. So there is always a way in technology to see it right. Yeah. Wow. I think I found a way. I accessed my camera from a different cam. So I'm publishing
your brain to work.
Yeah. So you could see I'm toggling a bit for every counter that is incrementing, and it is being sent here. So I hope the audience are able to see like what we are doing here. Yeah, that's great.
Yeah.
So from here, we just visualize the data in a Node-RED applications in a dashboard element. So let me show the dashboard element once again to make it clear. So we are using the MQTT element node from the Node-RED, and this is the dashboard element. I'm using it to see this counter variable that I'm incrementing. Yeah, so let me stop sharing so that Hugo could take it up from here.
Yeah, so maybe Rafael. The JSON that you sent, and he will prepare the configuration on his side while I prepare first the database. So what we want to achieve. So we have, as you showed, the MQTT broker is receiving now. It's the data from that device. We could configure more devices because we are able to, on that specific broker, we are able to get 800K message per second. Sorry, per second in some of the cases. So it's high throughput solution. So it's quite capable of handling that in terms of reception of messages. The thing is with databases, and Rafael needs to prepare that part, you're not able to do the same with the connectors because the databases, they cannot handle that amount of information. So we are going to do something to pick up the OPC UA message, and we are going to trim it to a table that what we really require, just to show as an example. So first thing, I set up on DigitalOcean, which is one of our partners. I set up a database, and again, we can show the password since we are going to delete this, but the password it's already here. You can see it, Joel. But
lovely.
Yeah. So I already sent this to Rafael. So what we have, it's a managed database already with everything set it up. So the benefit of using something like this with our broker is you are able to set up, as we have shown, everything in a very fast way. So we set up an MQTT broker. So we set up the infrastructure, the cloud infrastructure, and now we can go into Rafael demo.
Now we're gonna connect to asset. We just put this here. Just connect here to our PostgreSQL asset.
So maybe I can add in something. So this is the ROT management solution. So you're able to set up all the Flux assets that you have for each account. So is using his computer as the connector. So it's mimicking like either a droplet or a cloud service. So this could be running on a virtual machine. So we are setting up this connector within the broker, so it's able to connect to the MQTT broker and to pass the data to the PostgreSQL.
I need to log in.
That password probably you cannot show.
Yeah, I cannot.
I think I'll leave this one.
Okay, so now I'm able to download our assets. Scripts right here. Install.
So this asset, this connector is what he does. It's what it says. So it's converting from MQTT into PostgreSQL. So we can also later leave the link. Yeah, please go ahead, Rafael. Like, do explain what you.
Yeah, so
are able to
when
do
we
there.
open the configuration part, so we can find all the details needed to configure the MQTT parameters, SQL parameters, and as well the tag that we're going to use to receive data and then send it to our database. I already have it here, the configuration, so I'm going to import the config. So we
Can
don't
you show the
waste any time.
config on the JSON file?
Yeah, just a second. I think it's right here, but I can explain it maybe on the hub. So yeah, I already have the MQTT parameters to connect to the cloud broker that Hugo gave to Melvin, and already have the SQL details to connect to the database as well. I already filled the parameters needed to connect and to do our query. All of these, the route, publish, all of this information you can find in our lovely documentation. So right here you can see what's needed and what I have filled in terms of publish, routes. All of these you can find in our documentation. So it's everything already set up. MQTT topic that Melvin is publishing the data from the OPC UA, and the query that we're gonna do to publish in the DigitalOcean database. Talking a bit about the query, we can see here, maybe this part I'm gonna show on the JSON, or maybe after João can show a picture or something to be more clear. Here it's the columns that we're gonna put our data in, but the main thing that I want to focus on is the wildcards that CoreFlux handles. So, for example, the payload that comes from Melvin has a message ID, publisher ID, and as well has an array. So we can see that information by doing these value.json.messages, the array index, and then access the parameter that we want to. We also can use the wildcard not only for JSON but also for CSV. But all of this information you can find on our documentation.
One question, is that translating from the payload into a new query, correct? And creating a dynamic query.
Exactly that.
So Hugo and Rafael, I think giving a documentation for what we are doing in a one PDF will be a very good thing for the viewers. Like, what do you think after this recording? Maybe we spend some time where I give you some documentation with whatever I did, and then you put in so that they can download it with one link. Does that sound good to you?
Mhm.
Yeah, we can do
Yeah,
it.
we can do that.
Yeah, we'll make sure to link it in the description of this video, and also you can always send us an email so that you can receive this information as soon as it's ready.
Wow, okay.
Okay. So now I'm gonna save our tag and our configuration, and fingers crossed that everything's gonna work. So yeah, it's already running. Now I'm gonna use HeidiSQL to visualize our database. So let me get in. Okay.
Okay.
So now as you can see, everything is working as planned.
Okay, Melvin, can you stop the
Yeah,
on
sure.
your side?
Yeah, I have stopped it and it stopped.
Let me see. The last number is Rafael. The last number is what? The sequence number.
Sequence 3804.
Okay, can you check the MQTT?
Yeah.
So I think even I was capturing.
Sequence number is on here. Sorry.
That's 39. It's not that one. I think it's publisher demo.
Oh, see,
I think it's
Yeah.
Sorry.
3804. It's 3804.
Yeah,
Yeah,
it's
it's yeah.
yeah, it's the.
it's correct.
Yeah,
I
so
was
it's
looking to
even
Can
that.
you
I
show the
was
stopping.
database again? Yeah, can you show the database again, maybe?
Yeah.
Melvin, can you start maybe? Push and we
Sure.
refreshed. See.
But it's going to start from zero. Actually, I did not stop it. I closed the application.
fine.
So
No, it's fine. But this shows a way that we were able to build a full pipeline in this way. So we have data. Yeah, you have it. 1,
yeah,
2, 3, 4, 5. And one thing that you are able to see is that all the events are being captured. And bear in mind that this is actually running in Germany, and also we set up the connector on purpose in Portugal, so we can see it's working in a way that's keeping the information going and not losing all the events. That's something that we really focus on, because losing something, losing a message for us is critical. And I think at least what we wanted to do, what we wanted to achieve, technically we did. So I don't know, Melvin, if you have anything further, but maybe we can talk about
yeah.
OPCUA. What do you think about this?
So, so a quick, maybe a background about me. So I'm more of an embedded guy who, so even with OPCA, I'm a kind of, I've been always working on getting a publisher subscriber for real time. So where we send out a packet for every 200 microseconds for motion control and IO control applications. So it's especially OPCA plus TSN is what I do. But this is something that for an embedded engineer like me, it's so simple that I just push the data to MQTT, and with few clicks, I think we would have hardly done just clicks and very less coding here. I think it was mostly copy pasting that we did from the documentation, and a database is created is something that is quite interesting for me. I have seen the ways to store it on the local system itself, but to save it in a database, I think this tutorial would be quite interesting for people like me, at least, who's always with writing 10 lines of code per week, like embedded engineers versus full stack developers, right? So I followed a lot of tutorials to save data, but I think this is much more simple and easy, and we did it step by step. It was nice, actually.
The thing sometimes is that we actually we like to do stuff. We like to code, and sometimes it acts like it's so simple that we do like it, but at the same time we don't like it because we are not doing what we like to do, which is to change code. And in that way, I think I also feel the same. It's not proper visualization as you have in the test, but it's an idea that you have the pipeline mounted. Maybe we can. We have a couple of questions for you if you're interested on answering, because OPCUA, and I wanted to bring in that discussion about OPCUA and MQTT.
Yeah. Sure.
Maybe you can talk a little bit about if this is something that is competing against OPCUA, MQTT, or is something that really works together. What's your feeling regarding that? What do you see for the future regarding OPCUA?
What I see is there is a misconception among people that OPCA is just the legacy OPCA that people know it for. But with the new specifications and there are a lot of working groups inside the OPC Foundation itself, which paves path for real-time communication and also PubSub addition, like the Part 14 specification addition to OPCA gives you a plethora of opportunities that you could do with a single stack. So, for example, I even see people that you can see there are a lot of gateways in the market that where you need to if you're working with protocol X, I don't want to name any, you need to have a gateway to push it to the cloud. So imagine that. So let me bring back my presentation so that it's easy for us to understand. So previously with the legacy protocols, let me share my screen. So with the legacy protocols, if you could see here, to control this robot, you would need a protocol X, right? So which is a real-time capable protocol, and you need to get it working with special network and all the capabilities. So you can't even have a different ping to that particular port. That port is dead and just used for real-time communications. So now with the help of using OPCA publisher, so for example, this particular controller is going to send data to this robot directly. Since this robot and the controller both are running OPCA, with the help of OPCA over MQTT or even OPCA client server communication, and imagine this particular controller acts like a edge box. It's not a gateway, just an edge device for the entire
Yeah.
factory floor. It becomes so easy to push the data. And once you have the data, right, so you can do a lot of stuff. And also at BE Services, we also have a product which is an Edge AIoT device. Oops, I'm doing a product promotion here, but still, this will be quite interesting. So you can see here that since so this particular product can get the data from the OT, it can take it up and do Edge AIoT actually. So this is quite interesting is because we have the OPCA server is able to transfer the data to different medium with a secure in a secure way. So people are always afraid that okay, what happens to the security if IT and OT are together? That's where the question is, right? So you have transport layer security, you have network layer security, and then you have application layer security. So with these three things, I think you are pretty secure and you're okay to expose your device to the cloud. But still, if some people are worried that, okay, what happens if some hacker enters into the system or if something bad happens? And for these purposes, you can see like we can have a edge. You can do everything in edge using our Coligo box, where you can see that all the data that is streaming, which as a OPCA will be exposed, and then you can analyze, you can store, you can collect, and you can do all sorts of things, AI, everything on the edge. And it's possible is because OPCA gives you real time, OPCA pops up over UDP, it gives you for controller to controller communication, and then you can use OPCA over MQTT for the same application that we saw now. So this is the future is what I think. So as we discussed earlier, for the modern business use cases, we would need the IT and OT worlds to be integrated. Without that, I think we are still in industry 3 or industry 2, where we are in the mechanical revolution, or still we are not into the cyber physical systems where everybody can talk to each other, right?
Yeah, I get it. Maybe I don't know if Rafael has some questions regarding OPC Way because he's been developing something. Maybe what do you say, Rafael?
Yeah, yeah, I can go with some questions. The first one I would like to ask is like in a simple way, how the UPC way PubSub model differs from the traditional client server architecture, because for me as a junior, it's not clear yet the difference between the two of them.
Yeah, sure. So, what happens is, so let me show you an exact slide that would make sense to us. So, everybody knows that we need to create these variables, variable one, variable two, and variable three. So, everybody are familiar with this path. We're using OPCA as a client-server communication model. So what is PubSub is just packing these variables into a specific format. Okay, this specific format is what we saw in the JSON file. So this particular it's very simple. So for example, if I want to send the data PubSub over UDP, I need to create a connection, and then this connection will have a writer group, which is WG. From the writer group, you will have a writer, and inside the writer, you can map this field. So imagine motor position is data set one, and then if the motor speed is data set 2, and then you pack the packets and it's packed into a UDP frame and then it's sent out. So it is, for example, PubSub over UDP is brokerless because we need it for real time. So imagine you need to send a packet for every 100 microseconds. So you cannot expect a broker to be in between and also achieve real time. So in those modes, the middleware is there is no broker in between. It's a brokerless PubSub. So then if you want to port the same packet to the cloud, then we have the same values are encoded as a JSON format, and then you are pushed to the cloud using PubSub over MQTT. So it is just the transport layer is what it changes. So always there is a misconception, right? People say, hey, come on, OPCA is so complicated and MQTT is easy. I think this question will be there as a initial user of OPCA. So everybody should understand that MQTT is a transport layer protocol and OPCA is a standard. So what is the power of OPCA is? So imagine I have a sensor here, okay? If I'm going to publish it, there are going to be profiles where how this sensor data should be sent. So for example, let us take a temperature sensor value. The temperature sensor itself will have a lot of attributes like maximum temperature, minimum temperature. So the maximum value, minimum value is a degree Celsius or Fahrenheit, the unit, and also the range it can work. There are a lot of other parameters for a simple sensor. So imagine one value has at least 8 other attributes. So to pack these values inside an MQTT, you need to define your own standard to do it. But with OPCUA, for example, for plastic industry, there is a separate profile. For motor control, there's a separate profile. So everything comes with standards so that you buy a motor control. For example, I can show you a very good use case here. You could see this particular robot is from a vendor, is from a robot company called Neura, and this particular controller is from B&R. So since they both speak OPCA FX, they are defined in a standard for controller to controller communication. We are able to easily use the controller from a vendor A to control the vendor B. So imagine one company has robots that make robotic arms better, and then you have a company that makes sensors better. As a machine builder, I have this uh, freedom to choose my own method, own parts from different vendors, and then I can make a heterogeneous vendor independent system that would use OPCA, and I can get it all done with this standard. So this is the power of OPCA, and this is why I strongly believe that OPCA would be the backbone of modern industrial automation communications.
And one question regarding that. You talk about the OPC way on the, for instance, on plastic injection. So you're talking about more about AeroMap 77,
Yeah.
I think, that you can integrate OPC way with mesh. But uh, what do you think it's really so we all kind of know there is something that really doesn't fit in the market, but it makes total sense what you're saying. What do you think it's really the wall that OPCUA keeps finding? Is it that since it is a standard, you really need to really study it, otherwise you don't know it? it's lack of information? Is it within the OPC UA Foundation, the way things are deployed? Because I agree with you. I think it's not a matter of development or the tools that the SDKs that are done. But I really wanted to know your opinion. What do you think it is not
Yeah.
there yet?
I would say OPCA itself, like legacy OPCA itself, was used for a different purpose, and then now we are, at least in the past 10 years, the concept of OPCA plus TSN and OPCA publisher subscriber model was added, and then we came up with these lot of cloud use cases. So in the past 10 years, if you could see, the technology revolution itself went into a different curve. So to adopt this, there were a lot of changes and additions into the specification, and OPCUA itself is evolving, and then we are rearranging and we are creating the specifications that should match the current technology developments. So this is where there are a lot of new concepts, and I think the market is picking it up. And what I could see from 2015 versus 2024 is that there are a lot of devices, there are a lot of companies who are starting this adoption, and it's a general new technology adoption curve is what OPCA is going through. I think from 2017, when I attended a interoperability workshop, I was able to only connect to 2 or 3 devices. Now I was there in a Plugfest at Stuttgart a couple of weeks back. My device was able to talk with 14 other devices. So this is the evolution of the technology, and I believe that soon the adoption would increase, and also the technology and the standards itself is maturing. As you said, Euromap 77 companion specification is already available. Similarly, there will be companion specifications for all the different industries. So soon this would be widely adopted is what I believe. Yeah, so you need to believe in something, right? So
Yeah.
since I believe in OPCA, I'm going to talk for it. And yeah, so it's all about debate. So I also, being an engineer, I cannot say OPCA is the best for everything. So there are different protocols having pros and cons. It's up to the integrator and the service providers to decide on. For example, I would not suggest OPCA if you want to just toggle 10 IOs. Then you can just send, for example, for home automation, MQTT is perfect. I would not ask you to implement this huge OPCA stack there and do home automation, because MQTT is perfect there. All you need to do is different kind of topics, and then you send the data, it's done. So imagine an application where you have so many data points, so many different profiles. So there MQTT itself cannot be used. So that is where you need a standard on top of MQTT helping you to do things. So this is where, as an integrator or an engineer, you need to understand which is going to be easy for you and which is the best for you. And one size fits all concept is not available yet, I would say.
No, and I think the best part about technology is that it should not be like that. It should be, you should have a lot of contenders in terms of
Exactly.
standards,
Yeah.
in terms of companies, and you will get the benefits from each other. So I use it OPCDA, I use it OPCUA, I know OPCUA PubSub, I also use it MQTT. I strongly believe for the cloud, for the SaaS, MQTT is the best protocol, I would say, in terms of that's the thing I believe the best protocol in terms of to create a data pipeline. So bridging the OT to IT with MQTT, but you need to have something, like you said, you need to have something that structures data. And MQTT is kind of a whiteboard. If you use MQTT, it's kind of a white canvas that you can do wherever. There, of course, there will be people that are going to say you have Sparkplug, but that's okay. You have Sparkplug, you have OPCUA PubSub. You can even have your own way to mount, but it comes to a point that technology needs to really catch up from every position. In the end, what you mentioned, to really create Industry 4.0 is the number one goal, I think, for everyone, and that's the good part of it, the good part of having these different ideas. So maybe I'll pass to João Barroso. I don't know if
I was going to say we are approaching here on 1 hour, so if anyone has one last question that they want to ask.
I actually have one.
ahead.
So Melvin, earlier before you were saying that some people still find OPC UA a bit difficult. One of the things that for me is still like a nightmare, I will say, is like the security parts. So my question is, what are the main threats, the main security threats that OPC UA is designed to address, and how do these threats influence the need for such a wide range of security settings and configurations?
Yeah. So the security part itself is you could use your own. So for example, as you said, so OPCA itself is not going to define anything new in the security. So it's not reinventing the wheel. So we are going to use for example, if you are going to use TCP and IP communication, there are security methods that are well established and it is working already. So OPCA is going to use something that is already available because OPCA is sitting on the top layers and not on the layers where you need to define security. So this is the beauty of OPCA. If somebody is going to say OPCA over MQTT is not secure, then it means that MQTT is also not secure. If somebody is going to say OPCA client server communication is not secure, then TCP/IP is not secure. So this is where we need to conceive that. I would say this coffee mug is the transport layer, and whatever you pour inside is OPCA, right? So, for example, you can just, I think that's a bad example. So we can imagine a truck, right?
Actually,
A truck-
it isn't. You can put poison. Actually,
Yeah,
it's
you
a
can
good
put poison.
example.
So imagine this particular cup has different containers, then it would be a good a method. So I can say like, so imagine if this is MQTT, right? So you put one color inside, so color pen, and you put your normal pen, and then you send it across, then it's okay. So for example, if you're going to have like 10 color pens and 10 normal pen, then you could have a container that defines like, okay, the color pen should go left and the sketch pens should go right. This is what is OPCA is defining and nothing else. So when I'm sending this to UAO knows that on the left it's color pen, so that he takes it and sends it to the data, and this side is a blue color pen that goes on the right side. So this is what OPCA defines, and this container defines the exact security mechanisms and whatever it is, right? The QoS, everything comes under the MQTT technology itself. So I think if people are ready to say like, okay, going to put everything inside and I'm going to scratch my head once I receive, and then, oh, this is black, this is white, this is red, then it's their pain to do it. But if you want to make this easier, then you use something like OPCA, which defines the standard to say like, okay, once I receive the container, I know how the data is organized so that I can directly put it into my ERP, or put it into my dashboard, or whatever it is, right? So the security itself, I would say, to keep it simple, the security of TCP/IP is what is also used in OPCA. Security of MQTT is also used in OPCA. So transport layer security, network layer security, application level security with different user levels. You could also have levels for regular users, service engineers, access levels. Everything is possible in OPCA, which is also, for more details, you can also check the OPC standards, security profiles. This will give you a wide range of activities. So if you want to get into detail, I'm not an expert in security, at least on my day-to-day work. So we could also refer to security consultants at BE Services who could help us and consult properly to address your needs. Or not your needs, but whoever is looking for a perfect solution. I hope I answered your question.
Yeah, you did. Thank you.
Yeah. So, Joao,
All right. Very good. Melvin, is there any particular place or link that you'd like to share with people that we can put in the description and right now on
Yeah,
screen about
yeah,
finding
sure.
you on LinkedIn or anywhere else that you prefer?
Yeah, so I would suggest the audience to visit my LinkedIn profile, where I'll be regularly sharing guides for to whatever we are seeing now. So even this entire podcast where we send the data from factory floor to the cloud, I will be also publishing a PDF which you can download and repeat it at your end. So if I'm not publishing it on time, please DM me. I will share it to you across over email before the review process is done. But before it goes live, I would like to have a review round done with the team here. And yeah, I regularly post stuff on mostly on OPCA and also on other stuff. And I'm a technology lover and I'm always open to correct myself if I'm wrong. And I'm uh, quite happy that these kind of podcasts are there where the technology is openly available. Now, this gives the power to the people to choose what is right for them rather forcing what is right to them, right? So there is a huge difference between forcing a technology and giving the choice to people to test it. For example, if I say technology X is good and you should use it, that is wrong. What I should do is I say technology X is good. This is how you test it. Put it into your system, run it overnight, works for you, then use it. So this is how the technology adoption should take place. And you guys are doing an amazing job through these podcasts.
Thank you for that. I would like to obviously thank you for participating. I would say this was a success. We got the demo complete with time to spare for a great chat with all of you. Thank you, everyone that's on that side of the screen, for watching and listening. And whether you're just getting started or you're already a master of IoT, we hope to inspire you to find new and better ways to make your data work for you. We're happy to answer any questions you may have regarding this webinar or Coreflux in general. So just leave us your questions and comments below or email us at contact@coreflux.org. And make sure to connect with Melvin on LinkedIn, and also with the links for what he just said will be in the description of this video. We truly appreciate your enthusiasm and effort to put together the demo we saw today. So thank you so much, Melvin, for being here. Hope we can do something together again soon. And all right, well, consider subscribing if you want to see us make more content like this. And if you really want to help us democratize IoT, tell people about Coreflux. Thank you, everyone. See you in the next webinar.
Great show, guys. Great show.